Hey, greetings again. This is Brian Fields, amateur radio call sign W9CR. And as you can see, I have some radios here today, and I'm doing a little bit of work with them. These are the XTS2500 models, and they come with this board in it, which is it's a keypad and a crypto board all together. And what's kind of neat about these is these recently, and you can see this is a keyboard that goes right here, and it also functions as a cryptographic module in it. We're not so much concerned about that for ham radio, but one of the interesting things about these crypto modules, apparently in these that we got, these have been recased. They're not the original case, but don't know if you can see there. That is a very good quality BN radio, which means it's the 8 meg version. Supposedly can do extra trunking features and whatnot. But anyways, what happened with these is apparently Motorola made a special batch of these that were compatible with night vision equipment. And the problem, of course, with night vision equipment is a regular radio backlight is going to be way too bright. And these here are normal radios. I actually have I have a bone stock 900 megahertz radio right here. And let me see if I can get the light to turn on. You can kind of see the light turned on there. It'll turn off as well. If I hit this button, there we go. You can see it lights up the keypad fairly well. I'll do a little more when I get to it. But the problem is the regular, or this is the regular ones without crypto. The special crypto modules they made for the military or various users that needed night vision compatibility basically have no brightness at all. They're in daylight. You can't see anything. Even at night, it's very, very hard to tell. They're incredibly dim. And I've done some work. I did some reverse engineering. Not real reverse engineering, taking readings on the board, reversing the schematic from the board, what was there, and kind of how the normal version works, and comparing it, and figured out a way to take the crypto version, change out some resistors, remove a regulator, and make it work so that it's got nice, bright, backlight that hams want. Again, my use for this is amateur radio only. I'm not really concerned at all about the crypto. I would actually prefer not to have crypto in the radio because I'm only using it for amateur radio, and that's my purview in this. So let me show you a couple things here, and it's pretty easy to do. The only problem is it uses some very, very small components. Not the smallest. They're US size 0402 components, which they're pretty small. They're about half the size of the 0805 components, which are pretty easy to work with for surface mount. But I'll go into that, and I'll show you a little demonstration here of what one of these unmodified looks like, and then show you some of the stuff required to modify it. I also have this on my wiki page as well. And of course, if there's a better way to do it, please let me know. I've had somebody that has offered to, well, I should say this. I was researching this, and there's a person that sells the service to fix these. They won't tell you how they do it, which unfortunately I really don't agree with that. Any time where I sell my service to do something, I sell my service. My knowledge generally is free if you want to research it. A lot of times I may not have the time to answer questions regarding my knowledge, but anything I put out there, somebody can take it upon themselves and build upon it. So it's one of the things I really dislike, especially in some of the commercial radio circles, is people just don't want to help each other, and they want to think that what they have done is special or proprietary or something. Which, if you're trying to turn a couple bucks off a radio, possibly. One of the disturbing things about this, I have a friend of mine that had one of these done, actually paid to have his radio modified so that he could have good backlight. The way that the modification worked incorrectly was it was taking a regulator and shorting the output and the input of the regulator together So when the backlight would come on, it would draw about 1.2 amps because the regulator was getting really hot. So kind of a good thing there. Eventually the regulator, if it's on enough, will probably desolder itself from the board. That problem will go away. Or your battery will die. One of the two. Let me show you a couple things on this, how these look in terms of display brightness, and then I can get into the actual meat and potatoes of the modification. Okay, I'm going to try to show this as best I can. Lighting isn't ideal, but I think you'll get the idea. Anyways, this is a crypto module out of a 1.5, and it works pretty nicely. The problem is, you'll notice it doesn't have the little contacts on it, and it's missing the right here. You can see it's missing the LEDs as well. But I'll show you a normal one. Let me find my 900 radio here. So what I'm going to do is I'm going to show this what it looks like and shut the lights off around here. Okay, there's one. Okay, so the only lights that are on are the ones above me right now. And that's the intensity of it. And this is the normal stock radio, as it would be from the factory. Okay. Now, I actually already modified this other one here. This is an AES board that's in here. And what's interesting, the modified AES board that I have is slightly brighter than this. Let me see if I can... There we go. See, they're slightly brighter. I think that's just some normal variation. But it's close enough for all intents and purposes. Now this one here is a... Well, I had a problem with the radio. Let me turn this on. The antenna port was bad on it, and I had to replace it. But in the meantime, I got into this other problem. I'm waiting on the parts to come in on that. So it's just going to be a... well, it's going to be like this. And of course, I was trying not to touch the LCD screen. And the way these work, you see, is there's the LCD. And the LCD plugs into the keypad, which runs off the radio with this flex cable here. And this is the radio itself. It's all one, it's a single board type radio. So let me power this thing up by setting it on the battery here. Okay. Come on, sit on there. Okay. And of course I need to shut the light off. There we go. You can see how dim that is. Let me see if I can hold that on there and show this one at the same time. You can see it's basically barely legible. It does show up a little bit, but as soon as you get some light on it, you can barely tell. And of course, even this one's going to be in the case, which is going to have a little bit more of a attenuation of the the backlight. So anyways, what happened here, what Motorola did, is they added a 5-volt regulator before these LEDs. And what's interesting, the LEDs on here are actually in series. This one's in series with this and so on. These two are not, and they have different size current limiting resistors on these. And that's the big thing, and I'll show you how we fix some of that. Okay, let me take this off. I'm going to turn my lights back on here so we can see what we're doing. Okay. Kick this back on. Actually, yeah, we kind of need that, don't we? Okay, so first thing first, I'm going to get this out of here. Okay, so hopefully we don't break this very, very flexible thing here. Let me see if I can zoom in on it. I'm not certain if this is the real one or the aftermarket one, or if there's really that much difference anymore. You can see where I have a nice fingerprint right there on it, which I was trying not to do, but it just seems like that's going to be what happens. And then, of course, here the crypto module. Okay. And I'll set this aside. So this crypto module, if I orientate it like this, see a couple things. I've already modified this. You can see right here there's a this is the input and output of a 5 volt or 3 volt regulator. It's a 5 volt regulator in this configuration, and I'm just have removed it, and I'm shorting the B plus to the output of it, and the only thing this powers is the lighting circuits. So you know, I was very, very concerned that maybe it would overload something. That is certainly not the issue, and this radio is drawing very, very little current when you actually turn it on the way it's supposed to be. The previous way, since this is the input and this is the output, assuming the regulator's in there, what people were doing was taking the output line here and shorting it with the input line by putting a jumper in right there. Of course, that makes the regulator fight to try and keep its output, which is now shorted to 7.5 volts, at 5 volts, makes the regulator heat up, and things don't work very well because of that. And of course, that's where the what do you call it? Screen connects to it, and there's a very similar thing here. And I believe this is for programming some of the crypto stuff, maybe as from the factory. And of course, all the crypto stuff is all under here, and that's what does the crypto. And you can see the keyboard here. This is like a polyester special kind of tape, and these things are just held in place by that tape. These are I forget the name of the company that makes them. I have it on my my wiki. So I'll show you what we do here. Let me set this aside. So this might give you a better idea of the schematic. And this is just reversed. These are not official names. These are not anything. It's just simply my reverse engineering. So this is a battery coming in here, and 5 volts here goes to all these. And these are what's going to be on the dim version of the board. In the regular version of the board, well, number one, these two LEDs aren't placed. There's spots for them, but they're not actually used. And these 6.8K resistors here are actually 550 or 560 ohms. And these 560s are 330s. And you can see these here have two LEDs in series on them. So the current is required is more, so the resistance doesn't make a huge difference. I've actually experimented without changing these to 330, and I've not seen a huge difference on these. The big thing is getting them fed by 7.5 volts versus the 5 volts. That makes a profound difference on the keypad LEDs, but you're still required to change these resistors here. Actually, you really only need to change 2 of the resistors, but they're so close it's easy enough to just do it all properly, and it's done once. And then you can see here's your switch down here. Backlight enable goes high, pulls this, pulls it to ground. Very, very simple circuit. And I have this drawn up on my website as well as to what needs to change, and my designations that I've given the various resistors here. They're my own designation. I don't know. There's no schematic for this, so anything we know is what we know. So let me get set up here, and I'll do some of the rework and show you how some of that works. Okay, so probably what I'll show next here is how to actually disassemble one of these guys to get into it. Since I already had the one disassembled, I really didn't have to show that, but I think I will here anyways. Of course, you can get into it with the bottom button here, and I'll show you what the service menu is. This actually has a lot of keys in it from the factory, which is kind of interesting, or a lot of key algorithm supports, not keys. Normally you only have 2 or 3 algorithms supported in here, but this one you do. So it's kind of interesting. Well, first thing, take the battery off. And one of the things I will show, so these are the aftermarket cases, which are now available. I have, of course, a red one right here that I'm using. I like the red color. Ham radio, it seems to work just fine. You'll notice this has the test on it for the test port for doing pressure testing. These don't seal as well, and if that's a requirement, you really need to have the original Motorola case. Obviously, if you're using these in an explosive atmosphere, anything like that, why are you even watching this? Why are you even attempting this? You should just buy the proper product and have it serviced properly by somebody that is an official person to do that. You should not be attempting it yourself unless you're certified for anything like that. So, this is a case opening tool, and normally you sometimes can just pull these off. It'll mar a little bit, but you see how that works there. And you just go like that and then pulls the volume switch off. You can do that one by hand. And then this part here just lifts off. And, you have your antenna off. Make certain you're good there. You put this in this fashion. And you'll see how it kind of sits there. Okay. And pop it forward. And up and over like that. Simply push down. And here you are. So, of course, here's your one with your RF board and your shielding in place. I just pop these. Be careful with them because they're a pain to replace if you break them. Set that aside. And then you need to get at the shielding here. So first things first, you want to get this shield stuff out of here. And let me zoom in. I'll show you how that works. Okay. So you can kind of see here, there's a little bit of a space where you can get something in there. Same thing over here and over here. And you can use almost anything you can get in there. I'm just using a screwdriver in this point to give it some pressure and pop it out. But you want to remove this, pop this connector up first. This is the LCD screen there. And then everything else, once you get this shield out, will lift right out. Come on. Oh! Okay. Well, that's not ideal, but it'll work. One of the things you'll notice, sometimes this doesn't fit perfectly in there because it's an aftermarket case. So here is the crypto board and the UCM module. So that's how you get it out. Whenever you're doing work, you want to take this sticker off and also pop this. Be careful. Again, if you break this, it's not replaceable. This entire thing has to be replaced, and that can get pretty expensive. Okay, so I'm going to try to record this on the microscope. while I'm doing the rework here. So we'll see if that works or not. But basically, I don't know if you guys can see here, there's these 4 resistors right here. And I'll zoom in on this. Actually, I can record it. Let's see. Where's my recorder? Here we go. Let's see, mode. Video. And if I do this, is it recording? I don't know. Okay, it looks like I'm recording now on the this guy right here. So you'll be able to see these 4 resistors right here. If you see, ooh, this is really weird doing this. Trying to look here. Normally I look through the objective here on the scope. So these here are the limiting resistors. Right now these guys are 6.8K, 6,800 ohms, and they need to be changed to a much smaller value, 560 ohms, to limit what we're doing here. So let me get working on that. First thing you got to do is get the board heated up, because these guys require a lot of heat. So I normally have my little underboard preheater here. If you can see my setup, I have the underboard preheater, and I'll set that at about 500 degrees or so. The nice thing, that polyester holds up pretty well underneath there. And then just let this thing cook for a little bit and then go at it. So that's going to take about, ooh, not the best camera setup here. Anyways, that's going to take a little bit of time to warm up, so I'll be back in a minute. Okay, so what I find here is I need a lot more heat on the leaded free solder that ships on these boards. It's amazing to think how small these parts are, because they look so huge here. But I've sped a lot of this up so that we can get through it pretty quickly. A lot of this was just finding the right combination to be able to get this stuff off the board, because there's that kind of big ground plane there on the left side that everything buffers through. And once they actually reflow, you'll see the solder doesn't really look like it's reflowed, because it's the leaded free solder. I really prefer the leaded solder. The stuff just is so much easier to hand work. Obviously, for production, the reduction of hazardous substances, all that comes, when you have a professional shop, it's so much easier to work with. So what I'll do is I put down some clean flux here. I have a little flux syringe. You can really never have too much flux. I mean, possibly. And then what this does is it forms a new amalgamation of the alloy that's in there, the old solder, with the new leaded solder. And it's just regular 6040 flux core solder. And then I'll clean it off to prep the pads with, and this will get most of the other crap off there, the old solder, with some solder braid. And once that's done, the next thing is you put a little bit of solder on the pads for the parts to adhere to. I think in this case I end up using a little too much solder, but it really doesn't matter for this. It's not particularly critical. These aren't RF components or anything, and I would like to probably use some solder paste here in the future, but I'm perfectly happy doing this. I probably should have went at it with a little bit of braid to get some of this extra solder off there, but this is more than sufficient. There's of course a little bit of a shake as you work on this too. That's a big part of it because it's so small. Okay, so I have the first 4 resistors removed. These are the ones that go to the LCD screen, and they need to be changed out. And so what I'm going to do, have one of these wonderful Chinese books you can get on eBay. They're $25, $30 with all kinds of different stuff, and I need some 550 ohm resistors. Let's see, 1K6, 360, yeah, there you go. Right there. If you see, 560. So we're good. I'm going to pull these out, put a few of these very, very small ones on the board, and then go at it. And these probably aren't terribly critical. They use 560. It could be a 510 would probably be fine. A 620, you know, whatever you can do. So let me install these, and I'll be back. So this part here, what I'm going to do is just get the parts on the board. I already have some flux down. It may be a little bit harder to see here. In this case, as I said, I did put down a little bit too much solder getting started here. And they are a pain, but you can kind of see once they get reflowed and how much easier it is to work with the lead-free solder. Once they get reflowed, they just kind of self-center on the pad, and you know, of course, in this case, I sped a lot of this up, so you'll see it move here. I throw a little bit more flux on there, just kind of reflow everything and get everything self-centered. And you can touch it with the tongs there. So these are the resistors now coming off that control the LEDs that are on the keypad. I believe these are the top of the keypad. The 4 LEDs there go through these 2 resistors as current limiting resistors. So I'm going to be changing these to 330 ohm resistors. Because I believe they're 550 or 560 right now, and you can see there's basically no, oh, that one flew away. There's like no state change in the solder because it's this lead-free stuff. So same thing, I'm going to clean up pads, get the old solder off there, throw a little more solder down, and then throw my parts on there. It's so much easier working with the leaded solder. I'm just using standard 6040 leaded rosin core solder. It's some of the smallest solder I have. Actually, it is the smallest solder I have. And I have a real fine point for the Metcal. So we'll go over here. I'll do the other 2, which are right now in the center of the screen. These are for the bottom of the board, bottom of the keypad, bottom 2 rolls of the keypad there. And for whatever reason, the top one here just requires a lot of heat to get it off. Even with the preheater and everything going, and I know it looks like this is really big, but it's not. These things are grain of sand size components right now. And it's kind of infuriating because you know, you buy 3 or 4 of these, or you set out 3 or 4 of these parts to replace them, and they just blow away if you sneeze or whatever. That's the worst time of the year to work on any surface mount stuff like this is, of course, allergy season. So clean the pads up there, throw a little bit more solder down on them here, and try to be a little more judicious with my use of my solder. I don't want to throw too much down. And you could solder them down like this. I always like to have them facing the right way just because it's the proper way to do it. You know, it's the way that they do it in the factory. So, and you can see how easy that solder is to work with. So the final thing we're going to do is this voltage regulator. So, you know, of course, this requires a good amount of heat because it's on the voltage bus there, or you know, a real thick part of the board, especially with the ground plane. Throw a little bit more solder down, clean up pads, and all we're going to do is take the input, which is the pad on the left, and jumper it to the output. So we're going to have 7.5 volts sitting on the device, and that's just a little piece of jumper wire. So like I said, I use a little piece of jumper wire there and clean it up with some alcohol after it warms up or cools off. I use the 91% isopropyl alcohol, You know, it's not Freon 113, but supposedly it's good for the environment. Okay, well, I have the modifications done. Everything has been cleaned up here, and see, here's just a regular keypad board here. I pulled this out of my 900 meg radio, and of course one of the other ones here. I'm going to see if I can convert this to maybe a full keypad board by adding the missing parts to it. I think that'll actually work, because I already verified that these keys will work if they're shorted out. So let me turn some stuff on here. Okay. And I'm going to kill the light here. Whoop. Kill the lights. See, they're roughly almost the same. I think this one here, come on. I think they'll be about the same intensity. This one here might be a little bit brighter. And this one doesn't have a battery on it. I can throw a battery on that one here. Let me you know, I think some of that might be the maybe the angle that you look at it as well. Could be the battery. I think it could be definitely the battery. As the charge varies now, because this is sitting right on the battery voltage, the backlight display is going to change a little bit. I bet you if I swap those two batteries around, let's see what happens if the dimness that I'm seeing moves. And it does. It indeed looks like it does. So I just swapped the batteries on these two, and I think it goes based on the battery charge now. Come on. So yeah, these two are probably fresher batteries, and I'm going to guess if I move this back again, this one here should go to being bright now, relatively. Okay. I don't know. Might just be the screen as well. They're pretty close, but they're very, very much improved and certainly readable in good light now. So I'm going to consider it fixed. This is a 900. I took one of the AES boards and put it in here, just so I could have crypto in the radio for whatever reason. Play around with it, maybe, I don't know. And then, of course, I have this one here, which is a recased radio. Should have grabbed an extra battery. Let's see. So there we go. These were, as you could tell, definitely unreadable before. So anyways, I hope this was helpful, and maybe it'll spur some people to experiment with some of these radios a little bit more. Anyways, 73s to all. This is Brian Fields, amateur radio call sign, W9CR.